72,000 kilometers per hour. That's 20 times faster than a high-velocity sniper bullet. A rock the size of Mount Everest is screaming through the sky. For this monster, our atmosphere is no more than tissue paper. This is the Chicxulub asteroid. 66 million years ago, it shattered the silence of a world ruled by dinosaurs. It pierced through the sky in a matter of seconds, losing none of its terrifying mass before the impact. The strike was equivalent to 100 trillion tons of TNT. A fireball, millions of times hotter than the sun. But here's the terrifying truth. The dinosaurs didn't die just because of the rock. They died because of where it hit. The Yucatan was a geological minefield. Beneath the shallow water lay miles of sulfur and limestone. It didn't just splash, it vaporized the crust. The deep ocean might have trapped the toxic dust, but fate had other plans. The Yucatan strike was a surgical hit to the planet's life support system. To wipe out the dinosaurs, the impact launched a three-step execution. 1. The sulfur cloud, a toxic shroud that turned the atmosphere into a global acid bath and choked the sun. 2. The firestorm, molten rock falling from space, igniting every forest and turning Earth into a global oven. 3. The impact winter, years of total darkness and freezing temperatures. The food chain collapsed. For the dinosaurs, this was the end. But what about us? We have technology, science, and bunkers. Would they be enough? Today, a 10-kilometer rock is an instant game over. But what if the threat is smaller, a 1-kilometer killer? Let's start the simulation. Over the past million years, 1-kilometer asteroids have scarred our planet multiple times. Look at the Jamanshin crater in Kazakhstan, or Bosumtwi in Ghana, living proof that space can deliver precise, lethal blows. Scientists reassure us, in the next 100 years, we are likely safe. But there is a catch. Detecting a stealth asteroid approaching from the direction of the sun is nearly impossible. Our telescopes are blinded by its glare. There is at least a 5% probability that a civilization killer is heading our way right now. What happens when it reaches its target? We have several scenarios. Scenario 1, the deep ocean, the sea trap. It might seem like an ocean impact is good news. The strike should be cushioned, no dust, right? Wrong. For a rock the size of a mountain traveling at 72,000 kilometers per hour, the ocean's depth is nothing more than a thin film. The asteroid won't even feel the water's resistance as it slams into the seafloor with the same fury. Imagine the impact hits the deepest point of the Atlantic. Tsunami. A water dome several kilometers high will rise at the impact site. Within hours, waves as tall as a 30-story building, up to 100 meters, will erase New York, London, and Lisbon. Chemical attack. The impact will vaporize trillions of tons of saltwater. Chlorine and bromine will be blasted into the stratosphere. These elements are perfect ozone eaters. Ozone hole. The planet's ozone layer will thin by up to 80%. What will people in Siberia or Australia feel? You won't be washed away by a wave, but a month later, you won't be able to step outside during the day. Without the ozone shield, the sun will turn into a deadly laser, burning skin to the bone in minutes. Global acid rains will follow, obliterating your crops. Scenario 2, land impact, the global blackout. What if a multi-billion-ton rock targets solid ground? Do you think it's just a bigger explosion? No. It's a kill switch for the entire planet. Hitting land launches billions of tons of red-hot dust, ash, and soot into the sky instead of steam. The question, how long can the sky burn? The answer, several weeks. Incandescent debris ejected into space will fall back down, igniting forests worldwide. Earth becomes a global oven. Then comes the asteroid winter. The dust will completely block sunlight. Temperatures will drop by 15 to 20 degrees Celsius, even at the equator. You might ask, don't we have food reserves? Yes, but they won't last long. In total darkness, photosynthesis stops. Plants die, then livestock, followed by chaos in the cities. This isn't just a disaster, it's the stopping of Earth's biological clock. Scenario 3. What if? Our chance. Are we as helpless as the dinosaurs? Not quite. Unlike them, we have DART and a nuclear arsenal. Option A. Kinetic impactor. If we detect the threat years in advance, we can launch a heavy probe to simply nudge the asteroid, changing its course by a fraction of a degree. In space, that is enough for it to miss us by thousands of miles. Option B. The nuclear option. If detected too late, our only hope is a series of powerful nuclear charges. Our goal isn't to blow it into dust, which creates radioactive buckshot, but to vaporize part of its surface, using the reactive force to push it aside. Can we unite and act flawlessly under the barrel of a cosmic gun? That is the ultimate question of our simulation. But what if you don't trust governments to save you? Can you survive a civilization killer on your own? If you have a high-tech bunker, the answer is maybe. But it's more than just a basement with cans. Here is your essential checklist if you decide to wait out the apocalypse underground. First, air. You need industrial HEPA filters. Without them, radioactive dust and toxic ash will sear your lungs in a matter of hours. Second, water. Forget external sources. You'll need a closed-loop recycling system to drink the same purified water for years. Third, energy. Sunlight is gone. Your only hope is a compact nuclear reactor or a powerful geothermal pump. Fourth, food. Cans will run out. You need hydroponic farms and full-spectrum LEDs to grow calories in total darkness. And finally, hygiene. Your waste management must be flawless. In a confined space, a single infection will turn your sanctuary into a tomb. You will have to stay in this isolation for 10 long years. That is how long it takes for the dust to settle, and the ozone layer to heal enough for you to walk outside without a spacesuit. True survival isn't just about oxygen and calories. It's about the art of waiting for Earth's biological clock to restart. Who will inherit the future? Those who tried to save the world, or those who hid beneath it?